Hello, YouTubers. Welcome to the next long-awaited episode of Dr. Jet building the Dona Outrigger. Before we go too much further, let's talk about the Dona Outrigger. Actually, it's a copy of the Kep's mini rigger. If you look at it, you go, wow. That's the same thing, but here's what they got wrong. You see here in the profile of, where's my thing? In the profile of the main body, it looks like it gets deeper back here, but in reality, the tub is flat and it has just this little skid right here in the middle. And our Chinese factory has just copied this drawing and done what they did. Anyway, I think the the drawings or the arrangement I have will work just fine. So that's a little history on the Dona Outrigger. It was a tested design, and actually these things can still be competitive in European racing, provided you can keep the weight down. They normally run them with a 60-gram motor. I think I'm going to use something a little heavier than that because, quite frankly, this thing weighs a ton. I'm looking at, all up with a 1.8 ampere 2S battery, I'm looking at this thing being close to 750 grams when a competitive one would be less than 500, and probably 465, 470 would be optimum weight for a competitive racer. Anyway, let's talk about the boat itself. One of the problems I noticed about this, and this is the most important thing, this sucker is not square. If I hold the stern flush, look what happens here. And I've already worked on this a little bit, but this whole center tub is twisted. And if you got a crooked boat, I don't care what you do, it's not going to drive right. You're going to have it lifting sponsons when you least expect it. You're going to have it spinning out. It's going to be a piece of junk. If it's not square, it's not fair. Okay, so here's the most important step in building this boat. You got to have a building board. And what I did is I fired up my trusty CAD program and I calculated out some distances so that I could achieve the angles you want on this thing. And the angles you want are, you want your ski at 1.5 degrees, and you want your sponsons at 4 degrees. So using a little basic trigonometry, I calculated out some distances relative to some thicknesses of materials I have on hand, and voila, I have a building board. Now, let's do this. Let's show you just the sponsons, and with a little bit of work on the sponsons, I think I've got them pretty good. Now, you'll notice that when I did the ride surfaces on here, I had them taped together, so I did everything at the same time so the angles would all be the same, and I identified them as right and left. And so they're going to keep that identity until everything is all said and done. So what I did is I made a stop for the sponsons and calculated out a distance from the stop to the height of this material to provide a 4-degree angle. That's just, a little simple trigonometry using the sine of a 4-degree angle times or divided by the the height of this object right here. And so that gets my sponsons square. Now they're all at the same angles. And I made a crude little device here to measure how high this boom tube is and measure how high it is here, just to have an approximation for the tub. And when the tub is indexed and sitting at 1.5 degrees, I look at my little indicator here, and I am half a bubble off of plumb. And the same thing up here. I'm going to have to move these holes up because this whole thing is twisted this way. Now, the only thing that matters is this surface and these surfaces here. If this is a corkscrew here, it just won't matter as long as the relationship between this 1.5 degrees and this 4 degrees stays the same. This could come up and go over here and around here, and it just wouldn't matter. All that matters is this. So that is the most important step in building this boat and getting it to run right, is it's got to be square. The final setup, we're going to use the prop height and such that they've been using on the Keps rigger. And I was originally planning on a straight shaft arrangement, but after looking at the angles and everything, it didn't work as well as I thought it would. So I'm going to be using, where is it, right here in my box of parts. I made this nice little drive shaft, and I'm going to be using a 1/16 inch wire drive. And it'll have just a minimum amount of bend in it, and it'll be a solid, reliable drive system. I decided to go with an old Fuller hydro strut I had. It's a hydro strut in that it's got a flat ride surface on the bottom. Sharp edges, got to have sharp edges, right? So, but it actually has a little ride surface there. And what's going to happen is my stuffing tube's going to come out here. I'm going to have my Teflon tube. I'm going to put a piece of shrink tube over that whole assembly to keep water out. I did something fancy on the rudder. We'll talk about that on the next episode. I decided to go with one of Steve's motors here, just because I like the extra power and efficiency. So I'm going to use this little 1107 1.5Y in a helicopter mode. So there you go. For reaming out these holes here, just for basic reaming out, I've got a 6mm reamer here that's just on a little chuck that I can hand do. But this is going to require some serious modification. And so when this thing's all glued up and ready to go, there's going to be a whole lot of epoxy and cabosil. And you can see I shot a coat of primer on here because it was looking kind of ugly. And, I think I might just leave it this primer. It's not quite as white as the rest of it, but, who cares? It's just a rigger. So we're going to set it up to their specs. And it calls for a parallel strut here with the center line 6mm above the building board. That'll be easy to achieve now that we have a nice flat building surface. Got to have this. If you ever want an outrigger to run well, it's got to be square. it ain't square, it ain't fair. Anyway, so that's the end of this episode. Stay tuned for the next one. We'll be putting this together. We'll talk about weight. Just as an aside, I've been thinking of using an aluminum sleeve here that the boom tubes could be easily replaced. You can make it wider or narrower. But that's weight, and this thing's already a pig, and so I haven't decided. I do like the ability to swap things out. I don't like adding weight. So in my next episode, my indecision may have been mitigated. Have fun. I'll see you next time around.